Z versus T. Some YouTubers are getting it wrong. Some YouTubers are telling their students to use the z-test rather than student's t-test when n equals 30 or is not that much greater than 30 when the standard deviation is unknown and estimated from the data. That's wrong, and I will show you why. We're testing hypotheses about the mean of a normally distributed population. We have z-test and we have student's t-test. For both tests, the population has to be normally or approximately normally distributed. And for both tests, you have to use random sampling from the population. But for the z-test, the standard deviation is known or is assumed to be known. And for student's t-test, the standard deviation is estimated from the data. That's the difference, but it is a big difference. Now, the left critical value for a two-tailed one-sample student's t-test with n equals 31, which is 30 degrees of freedom, at the 5% significance level is negative 2.0423. The left critical value for a two-tailed one-sample z-test is negative 1.96, and you might be familiar with that number. Please notice the difference. In this world where alpha equals 5% is sacrosanct to so many, it could matter. Indeed, if you use a z-test when n is close to 30, but when the standard deviation is not known, but is estimated from your sample, your confidence intervals will be too narrow, and you'll reject the null hypothesis with a higher probability than the nominal significance level. So you'll be more likely to commit a type 1 error than that specified by your alpha value. But to be fair, if your p-value is way below the significance level using a z-test, well, then it won't matter. But still, use the appropriate test. And at the very least, if your p-value is observed to be not that much below the significance level, then use the correct test, student's t-test, to make sure you are really working at the specified significance level. Thank you for watching this highly technical video.